Alright, in this test we are going to get data from the ADC and transfer it using DMA to the microcontroller's onboard RAM, and then from there, once that DMA transfer is complete, we'll copy it back over UART and analyze the data. Hopefully we'll be able to get to a megasample per second and therefore be able to see a 100 kilohertz sine wave and see 10 samples along each cycle of that wave. So we're going to start with our XMega board and programmer hooked up. We are once again going to rely on our handy-dandy diagnostic program, which this time has been outfitted with our ADC DMA test, which is going to do a DMA transfer from the ADC for 1,000 samples. Then it's going to stop for a second and then write that data sequentially over the UART. So the UART communication isn't done by DMA in this case, just the transfer from the ADC into memory. And then from there we'll do it again once every second. So we'll program this, and it programs without error. And before we hook it up to a function generator to actually record a signal, we're going to hook our function generator up to the oscilloscope and make sure we get a 100 kilohertz sine wave. So I have this set up, 100 kilohertz. We have a DC offset of about 2.5 volts to make sure that all of the values the ADC will be reading will be positive values between, actually what am I saying, it's a half a volt, to make sure all of the values are between 0 volts and 1 volt. The internal reference on the ADC is 1 volt right now, so that's the maximum we can record with the onboard voltage reference. So here we have our sine wave. It's 100 kilohertz, as you can see, 856 millivolts peak to peak, so we're within the 100 or the 1 volt range, minimum of 100 millivolts, maximum of 964. So we should see our 8-bit ADC values swinging pretty close to 0 and pretty close up to 255, the maximum value. Probably somewhere in the range of 30 or 40 up to 240 or 250. So for this test, since we already have it programmed, I'm going to quit Vim, and we have a short Python script courtesy of Mikhail, which converts the binary values which the microcontroller will be sending into ASCII characters so we can actually read the values, called raw data get, and we're going to put that in a file. So we'll let that run for a second. As you can see, once every second or so the UART blinks when it's performing the transfer after the ADC has completed 1,000 samples. So that's blinked a couple of times. We can quit that. And now if we look at the file, what we get is a bunch of 0 values for a while. This is the DMA transferring zeros while the ADC is starting up. That'll happen for quite some time. And something went wrong. That is phenomenal. Oh, well, you know, it doesn't work very well when you don't hook up the function generator to the ADC input. So we're going to go ahead and do that. So looks like the pin is just floating right around ground. We have a wire for ground, and we'll hook the scope up to that as well. And this is port A, pin 2. It's our ADC input. And we'll hook the scope up to that as well, so we can see we still got our sine wave up there. So we'll go ahead and do the data capture again. Let it go for a few seconds. Again, the light blinks periodically. And once again, we view our capture file. We have a lot of 0 values. And then we start getting what looks like a sine wave. highest values here are 255, 252, so this is the peak of a wave. And now if we look, here's 252, we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 samples. That takes us again to 252, surprisingly, right on the money, the peak of the next wave. So this gives us 10 samples along one period of a 100 kilohertz wave, meaning that indeed we are sampling at a megasample per second.